welcome to section 12.2. We're evaluating the limits that we did in section 12.1. Now the last question we answered in section 12.1 was a limit where we could not directly substitute. And so look back at that real quick and see what I'm talking about. But this is the idea. What happens when we can't direct substitute? So if you take a look at this first example, we have x squared plus 2x minus 8 divided by x minus 2. If I take the limit as x approaches 2 and I try to plug that in, what I get on top, 2 squared, let's do it this way, 2 squared plus 2 times 2 minus 8. Well, 4 plus 4 is 8, minus 8, we get 0. In the denominator, I get 0 as well. 0 over 0 is what we call indeterminate form. Please know that word, that's coming back on quizzes and tests. Indeterminate form means it's not a possibility to evaluate a limit when you do direct substitution. And so we looked at two other methods yesterday for evaluating a limit. The first one was graphically. And so I want you to put this in your calculator. Don't forget parentheses on top and parentheses on bottom. But what you end up finding is you get the 0.1425 0415, we get an error because we can't put a 0 in the denominator. And you get this line, and it's just like the examples that we did in our notes the other day. And it looks like this, where you have a hole at the value of 2. And we said you get a hole if you look at your equation. So I'm looking at x squared plus 2x minus 8 over x minus 2. And we said if you could factor out something from top and bottom. Well, to get a negative 8, it's got to be 4 and 2. And the 2 has to be negative in order for it to be a positive 2 in the middle. You'll notice these cancel out. So at 2 is where I'm getting the whole. And so what I'm left with is x plus 4. And so if we look at this, we said you could also do it numerically, where you had 5.9, 5.95, 5.99, 6.01, 6.05, and 6.1. And again, here it looks to be approximately 6. And so we would say the limit of our function as x approaches 2 is 6. And we talked about this idea of a whole, and we're going to talk about this thing called dividing out. And so this is something that we did basically in the last lesson. So let's go down, see what we can find. As we look at this, direct substitution is much faster, but you, again, will get indeterminate form. So we factor like we did before. And if I factor things out, there's where my whole is, and I'm left with x plus 4. If I use my factored out version, I can take the limit as x now approaches 2 of the quantity x plus 4. So 2 plus 4, because I plug this in for x, equals 6. And we said that was the limit as I looked numerically and graphically above. Now, this method of factoring out and then being able to direct substitute is what we call dividing out. So let's try a couple examples and see how they work. If I start in the first one, I'm just going to work with the factoring now for a minute. If I try to substitute, what you end up getting is 0 cubed, which is 0, minus 4 times 0 is 0, minus 21 times 0 is 0, over 0 plus 0 is 0. So I get indeterminate form. So direct substitution didn't work. So what we're going to do is factor first. I can take an x out of the top, and I'm left with x squared minus 4x minus 21. If I take an x out of the bottom, I'm left with x plus 3. And if I look, again, the x's can cancel out. What our goal, though, is to say, can you factor the rest of this? Well, 21 is 7 and 3, which can get us 4. So x minus 7 and an x plus 3 all over an x plus 3 these factors cancel. So what I'm left with then is now to use my direct substitution again. The limit as x approaches 0 of my new function, x minus 7, well, if I plug a 0 in, 0 minus 7 is negative 7. And so I can now use direct substitution once I've factored things out to find the limit as x approaches 0. What you will want to do is, again, put this in your calculator and graph it in order to check it. And again, you want to do that to make sure that you know how that works graphically and numerically, like our tables above. Okay, let's try another one. As x goes to 1, if I use direct substitution and I plug in the 1 there, 1 minus 1 is 1. 1 cubed is 1, minus 1 squared is 1, plus 1 minus 1, everything cancels out. 1 minus 1 is 0, so I get 0 over 0. That again tells us indeterminate form. See how close I can get? So since that happens, we're going to factor this. Now, this factoring is a little different, which is why I like to have this one on there. This I have an x minus 1 on top. What we said in Algebra 2 and the first part of pre-calc is that when we're factoring something with 4 terms, we use grouping. So I'm going to group these two together. If I pull an x squared out of the first, I get x minus 1. If I pull a 1 out of the second, I get x minus 1, since there's nothing in common. So what I end up doing is I have an x minus 1 on top, and I can pull the x minus 1 out of both parts in the bottom, and I'm left with x squared plus 1. These cancel out. So since they cancel, I now can take the limit as x approaches 1 of my factored form, 1 over x squared plus 1. And if I plug this in, 1 over 1 squared is 1, plus 1 is 2, so I get a value of 1/2. Again, our suggestion is that you go back and graphically check that or numerically check that just to make sure. But this is the general idea. If you plug your number into direct substitute first and it doesn't work, then you need to factor it out first, or divide it out as we call it, and then directly substitute whatever your answer is at the end. So let's flip to the back. Let's try another one. All right, take a look. The second one is called rationalizing. And so we're going to look at this one because we also get indeterminate form here. So if I'm trying to just plug in my denominator, if I'm just trying to use direct substitution, if I plug 0 in, I get 0 plus 1 is the square root of 1, which is 1. 1 minus 1 is 0, over 0. And so because I get this indeterminate form, I need to look at being able to do something else with it in order to use direct substitution. The problem is you can't be factored. So what I have to do is use a technique from previous courses and use it that way. Now, we used to have a square root in the denominator and say didn't like that, so we try to rationalize it. Same thing, only this case, because the square root can't stay in the numerator, or I get an indeterminate form, I'm going to rationalize the numerator. So I'm going to multiply by its conjugate, the square root of x plus 1 plus 1 on top and bottom. Now, if I do that, and I'm going to put parentheses around here, if I FOIL this, I get an x plus 1, and then I do this positive square root and a negative square root will cancel, and then I get minus 1 all over x times this square root. And I'm going to leave it out here just for a reason, and I think you'll see in a minute. If I try and simplify, these cancel, and so then I'm left with an x on top and an x on bottom. Those cancel. So now that I've rationalized this, I can start my limit. The limit as x approaches 0 of 1 over the square root of x plus 1 plus 1. Once I'm here, the question is, can I do direct substitution? Well, sure. If I plug this in, I get 1 over the square root of 1, which is just 1. So 1 plus 1 makes 2. I get 1/2. And again, what you should be doing is graphing it in order to check. Okay? But this is the idea. If you plug it in and you've got these square roots, you're going to have to rationalize the numerator this time in order to make it work. Now, next one talks about using your calculator. And what you'll need to do is use your trace button. Okay, so this value right here, you plug in your calculator. And what you'll want to do is try and trace over to 0. What I'm going to do actually is hit my trace button. And you know what? Let me actually show you while I'm there. I've got my calculator up, so let me show you this. If I go in my y equals, and I put this in as 1 plus x to the, and I want this exponent to be in parentheses, so to the 1 over x, and now I'm going to hit graph. And the question is, what value do you get really close to as we go to 0? Because we are asking you, basically, what is the limit as x goes to 0 of this function? Okay, so I'm going to try and, I'm trying to figure out what is this value as close and close and close to 0 as I can. So what I'm going to try doing first, and this won't show up, but let me do this, is I'm going to try and trace, and what I want to do is pick a value really, really, really close to 0. So I'm going to do 0 point, and I'm going to do as many zeros as this will kind of allow. And I'm going to stop because I might be going too far. Yep. Let me go back because I want to be able to see this. I'm going to put a 1 in there. You've got to be able to see it in your window or your grapher won't do it. And it looks like since I have still this dot, 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 I better get rid of a few more. Let's try this. If I press enter, what you see is I have 1 times 10 to the negative 8. So that's really, really close to 0. And again, you're trying to get as close as you can. So what's the value that it's approaching? We're going to say it's approaching, our limit is approximately 2.718. And your goal is to pick a value that's really close to 0. Pick a value close to 0. But you only want to pick a value that's in your window. So you could do probably, you know, like 1 times 10 to the negative 15th if you want, as long as you put it in scientific notation instead. So just kind of keep that in mind. And again, this is one that we're going to kind of play with as we go through. So let me go back to the notes. And let's take this down and we'll try a couple more. We're going to look at one-sided limits. And we want to look at, this is a question that we actually did in yesterday's note. And so I want to look at the graph. If you put this in your y equals, we talked about this idea of what the graph looked like yesterday. And this is at 1, here's at negative 1. And we said there was an open circle, otherwise it's not a function. And as you go to the right, your value is 1. And as you go to the left, your value is negative 1. And what we asked you yesterday is basically what is the limit as it approaches 0. Well, it does not exist if it's a two-sided limit. And this is asking you to approach 0 basically from both directions. And so this one right here is a two-sided limit, which we said does not exist because it approaches 2 different values as you come to 0. Second thing, though, is what happens if it's a one-sided. And in one-sided limits can exist even if a two-sided limit doesn't. The way we write that is we say the limit of our function as x approaches 0 from the left. And we use a little negative symbol, and that basically means from the left. And as I look at the left, let's look at the left-hand side. I'm starting here. As I go to the left, what y value am I at? Well, my y value is at -1. Okay, well, what if I went from the right then? I take the limit as x approaches 0, and we use a little plus sign for the right of my function. As I come from the right, what y value am I at? I'm at a y value of 1. And so there's a difference. If you're trying to approach a limit from both directions, then it has to approach the same value. But if you're only trying to approach it from one direction, then it doesn't matter if it's going to two different places because you only care about one different side. And so this is kind of the idea. If they have the plus or the minus to say from the right or from the left, a limit could exist. If they don't tell you, then they're asking you about a two-sided limit, which means it may not exist. So this is kind of something to keep in mind, and we'll do more two-sided limits in class. Let's do our last one. We are asking you to take calculus, and we're doing the limit of a difference quotient. Okay, so take a look. Given the function x squared minus 1, find the limit using the difference quotient. So here we go. The difference quotient, if we go back, we want to first say, can I just plug this in? Okay, you always want to try substitution with a limit first. So if I use substitution, I plug in a 0, f of 3 plus 0 minus f of 3 all over 0. Well, I get f of 3 minus f of 3, which is just 0. So 0 over 0 says I have an indeterminate form. And I'm running out of room, so I'm going to shorthand that. Okay, so if that doesn't work, then we actually have to use the function that's there. So here's what we do. Let's go back to our difference quotient. We're going to take this limit and we're going to evaluate it as h goes to 0. All right, 3 plus h squared minus 1 is this first part. I'm going to put that in a bracket because that's this f of 3 plus h. Minus f of 3 is when I put this in. So 3 squared is 9. 9 minus 1 is 8 all over h. Now, don't forget this has to be FOILed out. If I do that, here's what I get. 9 plus 6h plus h squared minus 1 minus 8 all over h. And I'm going to simplify this a little bit before I bring the limit back. Well, 9 will factor with the negative 9, so I have 6h plus h squared all over h. And this is where we get this idea to divide out. And so this comes back to that divide out section, or factor it out. If I take the limit as h approaches 0, I can factor out an h from the top. Oops, 6 plus h. And so now I can take the limit of 6 plus h because that's my divided out quantity. Well, if I plug the 0 in, 6 plus 0 is just 6. Now, what this means is we're taking the derivative at x equals 3 for the function x squared minus 1. What that means is the slope of the tangent line is 6. And we're going to talk about what in the world a derivative or a slope of a tangent line or whatever that is Mr. Vanik's talking about. What in the world that is. Our lesson for tomorrow is this idea of a tangent line. And so I'm going to discuss more of that. But what we did is brought back a little bit of difference quotient. So that's it for section 12.2. Again, we'll work more in class. We'll do a warm-up and things like that. But just kind of keep in mind, always try and substitute first. If you get indeterminate form, then try and factor.